Hey guys, so today we're going to do section 3.2, Introduction to Functions. Last class before the chapter 1, chapter 2 test, we started chapter 3, which was the coordinate plane and just identifying and being able to graph points on the coordinate plane, the distance formula, the distance between 2 points, and also the midpoint of 2 points. So let's talk about functions. So let's first start with a relation. So a relation is just a set of ordered pairs. It can be any set of ordered pairs. So in this case, we have 1, 2, 3, 5, and negative 7, 9, which is 3 different points on our coordinate plane. Our inputs are 1, 3, and negative 7, the x values, and our outputs would be 2, 5, and 9. So that is a relation. In order for a relation to be a function, every input can only have one output. How I think about this is, think of a machine. If you input the same thing into the machine every single time, if the machine is working, it is going to give you the same result every time. So in this case, when you are looking to see if a relation is a function, you have to make sure that all of your x values are unique. Negative 1, 0, 1, and 2. So in this case, it is good. So if you want to put in here, no repeated x values. Big and very important. All right, so domain. The domain is the set of all x values, your inputs. So in this case, I underline the x values here. So our domain of this function right here would be negative 1, 0, 1, and 2. So that's our domain. We write that as a capital D, and notice we're using roster method. The squiggles here, and then each element is separated by commas. The range. The range is your outputs, the y values. So in this case, our range is 2, 0, 3, 0, and it is okay that we have a repeat in y values. That is allowed. So our range, in this case, just writing them in least to greatest, we had 2, 0, and 3, and 0 was repeated. You don't need to write 0 twice, and then 2 and 3. So the set of all y values. So domain is inputs, and range is outputs. A lot of people get them backwards and confused. How I remember it, D comes before R in the alphabet, so domain comes before range, so input and then output. Hit pause, take a minute, and write all of this down so you have it in your notes. All right, so let's see if this will move for me. Okay, function notation. The other day when we were graphing, the 3 graphs we graphed, one was a line, one was a quadratic, and one was absolute value. All of them were written as y equals. Well, now when we are dealing with the equations, we're going to come across a lot of equations that we're talking about at the same time. So instead of writing all of them as y equals and having to label them line 1 or equation 1, equation 7, what we do now is we give them this function notation f of x, and the letter f could change. So the way that you say that out loud is f of x, and that means f is our function with our independent variable being in parentheses, which is x in this case. All right, so let's look at an example here. Let me see if I can still go down. All right, so we have a function here, f of x equals 4 minus x squared right here. We are going to evaluate that function with these 1, 2, 3, 4, 5 different ways. So I'm going to do the first couple with you, and then you guys can do the other ones on your own. So f of 2. F of 2, what that means is 2 is replacing the independent variable x. So 4 minus x squared. I am replacing x with 2. And I am solving that out. So in this case, this will be 4 minus 4, which is 0. So f of 2 equals 0. The reason I like this notation is, in the answer, you see automatically here your input and your output. So the point on your graph would be 2, 0. Instead of you having to look back and say, ooh, where did it say what value was x? You have the value of x. X is the one inside the parentheses, and your y, because f of x represents y. Your y in this case is 0. So go ahead and take a minute and find f of -2, the second one. Hit pause and find f of -2. Alright, if you did 4 minus -2 squared, you would get 4 minus 4, which is also 0. So f of -2 is also 0. Just making some room here. Alright, 2 times f of 0. A lot of people get confused with this one. 2 times f of 0. That just means you are finding f of 0 and then multiplying your answer by 2. So f of 0 is, so 2 times your f of 0. F of 0 is 4 minus 0 squared. 4 minus 0 is 4. And 2 times that answer is 8. So 2 times f of 0 would be 8. All right. Next two, we have f of h, I believe. Let me look back up for a minute. And f of x plus 2. All right, f of h, sometimes your input variable is going to be something other than x. A lot of times when you have a real-world problem dealing with time, instead of writing f of x, your equation would be f of t, the letter t for time. So all you have to do for this one is you are replacing your variable x with h. So this is what the formula would be. You're just changing what your variable is. F of x plus 2. 4 minus x squared. We are replacing x with a whole new expression, x plus 2. X plus 2 squared is the same thing as x plus 2 times x plus 2. I'm running out of room. X plus 2, x plus 2. We have to distribute the x's, so x squared plus 2x, distribute the 2, 2x plus 4, combine like terms, and all of this is coming after a subtraction sign with the number 4. So this will be 4 minus x squared minus 4x minus 4. Our 4's will cancel. So this one is negative x squared minus 4x. It's a whole new equation. So f of x plus 2 is negative x squared minus 4x.